The link to the question is in the description, along with any resources that you might find helpful if you get stuck. Complete the question and try and do it in the time that's suggested. Once you have done this, continue the video to see the answer and the explanation. So the first thing with any question is to read it carefully and to try and think about what it's asking you to do and how we can best make use of all the information. So it is asking us to complete the sentences and to choose the answers from the box. There are only 2 spaces, but 4 responses. So as the cyclist accelerates, the something energy store in the cyclist's body decreases. So we've got 2 pieces of information. We've got that the cyclist is accelerating and that an energy store is decreasing. So we need to be thinking, what does a cyclist have as an initial energy store? So of these, chemical, elastic potential, gravitational potential, and kinetic, we need to think, well, it is a flat road, so it's probably not going to be gravitational potential. It's accelerating, so kinetic's not going to be increasing. Elastic potential doesn't have anything to do with this one, so it must be chemical. The cyclist's body decreases and the something energy of the cyclist increases. Well, it's not going to be chemical, that's decreasing. It's along a flat road, so it's not gravitational. We're not stretching anything, but we are accelerating. That means the speed is increasing, so that is going to be the kinetic energy, because of course kinetic energy is related to the speed of an object. Now for our next one, we've been given some information first. So the mass of the cyclist is 80 kilograms, the speed of the cyclist is 12 meters per second. Calculate, so that's our command word in this one, the kinetic energy of the cyclist. And in this case, we have been given the equation. So for all calculation questions, I would recommend using the concept of EVs. So EVs is like this. It stands for equation, variables, substitution, and solve. So each of these are important steps that allow you to get marks along the way. So in this case, the equation has been given for us. We've been told that Ke, or kinetic energy, is equal to 1/2 times the mass times the speed. Oh, let's move that over. Times the speed squared. Okay, so we've been given that this time. The next step is the variables. This is the point where you write out all the information in the question related to the variables in this equation, and it's also the time that you can convert things into base SI units if you need to. So what do we have? We've got the Ke. Do we know what that is? No, that's not been given to us. That's what we're trying to find out, so I just put a question mark. 1/2 is 1/2. We're looking for the mass. The mass is equal to 80 kilograms. And then we're looking for the speed. The speed is equal to 12 meters per second. We now do our check. Are these all in base SI? Well, that's going to be in joules when we do it. Kilograms, yep, meters per second. Perfect. So that is our variables. We've shown the examiner that we're able to take the information from the question and put it into ours. So now we need to substitute it in. So kinetic energy is equal to 1/2 times the mass, so 80 kilograms, times the speed, and we need to square that. Okay, so we've shown the examiner that we've taken the information correctly and we put it in. This means that if we mess up with our final calculation when we're putting it in the calculator, then we're not going to lose all the marks for that. So now get the calculator out. Put it in, 1/2 times 80 times 12 squared. That is going to be equal to 5,760 joules. Okay, we can do our basic check. Does that sort of seem like the right number? Yep. Yeah, so we've got that. And then later on, if you've got extra time, I would always advise going back and then just putting the numbers back into your calculator again. So we did the equation, it was written out. The variables, we wrote them out and we checked that they're in base SI units. We substituted those values in and then we solved. The solve section is where if you've got to do any rearranging, that will be the point that you do it. Okay. Moving on to part C. In part C, we're told that the cyclist uses the brake and the bicycle is slowing down. We're given some information and we're told to calculate, so there's our command word, the change in thermal energy of the brake pads. And again, we're being given the equation this time, that change in thermal energy is equal to mass times specific heat capacity times the temperature change. So again, we're going to go through the EVS process. So equation, variables, substitution, and solve. So we've been given the equation again. So the change in thermal energy is equal to the mass times the specific heat capacity times by the temperature change. So you may see this as delta theta in your exam or delta T. Both are correct. So now we've done the equation, so now we can do the variables. Delta E is equal to, we don't know. The mass is equal to 0.040 kg. The specific heat capacity, that is going to be equal to 480 joules per kilogram per degree C. And then finally, delta theta. Delta theta is an increase of 50 degrees, so it is a positive change of 50 degrees C. When you're doing other questions related to specific heat capacity, this is one you've got to be really careful of, as you might have to do a mini calculation here if you're told a starting and finishing temperature, because it needs to be the change in temperature, not just the end or beginning temperatures. Okay, so we've now got these. We can check, are they base SI? Well, that's the one we're looking for, which will be in joules. Kilograms for mass, yep, that's fine. Joules per kilogram per degree C, that's fine. 50 degrees C, and that is my change in temperature, so that's fine as well. Now I need to put the values in for the substitution. Delta E is equal to 0.040 times by 480 times by 50. Then we put this into our calculator again. 0.04 times 480 times by 50. 960 joules. Okay, so there we did our solve. And then we need to make sure that we write it there. So there is plenty of space on your paper to write out each of these steps. And if you do them neatly and carefully, then it makes the examiner's job much easier, and so they're much more likely to give you the marks. Now on to part D. How is the internal energy of the particles in the brake pads affected by the increase in temperature? Well, we need to remember what internal energy is. Now, internal energy, this is the energy that is held within the particles, and it is equal to the combination or the sum of the potential, that's the energy within the bonds, plus the kinetic energy within the bonds. So if we've increased the temperature, actually what we're doing is we're increasing the kinetic energy within those particles. So the internal energy of the particles in the brake pads is going to be increased. We've increased the thermal energy, that means we've increased the kinetic energy, and so the internal energy overall has been increased. If you didn't find this video helpful, then please click the dislike button and leave a comment below about how this could be improved. I really find constructive criticism really helpful, so thank you. If you did, however, find this video helpful, then please leave a like and consider subscribing so that you're notified about more content when it comes. If you have any questions about this or any other part of physics, then please leave it in the comment section below. If you have a particular request for a video about some content, then please also leave a comment below. I hope you found this really helpful. Thank you.